This is problem 15 on page 79, and let's read through it. It's an initial condition problem. I like to do initial condition problems in each topic when it makes sense. E to the x parentheses y cubed plus xy cubed plus 1 dx plus 3y squared parentheses x e to the x minus 6 dy equals to 0. And the initial condition is y at 0 equal to 1, which means when x equals 0, y equals to 1. Well, let's first check to make sure it's an exact differential equation. So to do that, I take the partial with respect to y of the left-hand coefficient, which is e to the x parentheses y cubed plus x y cubed plus 1. Okay, and we have a product rule here, this function times this function, but when we take the derivative with respect to y of e to the x, we'll get 0, so it's 0 times this function, which is 0, plus this derivative times e to the x. So I end up with just simply e to the x times this derivative, and that derivative is 3y squared plus 3xy squared plus 0. Okay, now we want to verify that that equals to the partial with respect to x of the right-hand coefficient, 3y squared parentheses x e to the x minus 6. And again, it's a product rule, but the derivative of the first piece of the product is going to be 0. So 0 times this function is 0, plus this derivative times 3y squared. So the derivative of x e to the x minus 6, here I have another product rule. So derivative of x is 1 times e to the x plus derivative of e to the x times x, and then 0. So did that equal to this one? Well, if I if I bring out the e to the x, but multiply the 3y squared through there, I did get partial respect to y. Alright, so these end up being equal, which makes it an exact differential equation. Well, we expected that because it's in this section. However, faced with a test, you may have to verify whether something's an exact differential equation or not before you can legitimately use that technique to solve. Alright, so the verification stuff we just don't need. We can erase it once it's verified. And now our solution will be z or f of xy. We integrate e to the x parentheses y cubed plus x y cubed plus 1 dx. And here we treat y as a constant and x as the variable. Alright, so this will probably be a little bit of an effort here. I'm going to multiply this out, so I'm integrating e to the x y cubed plus x e to the x y cubed plus e to the x dx. So I multiplied the e to the x through there, and this is the one that's going to give us a little bit of a trouble here. Again, we're treating y as a constant, so when I integrate e to the x times the constant, I get e to the x times the constant, so it's e to the x y cubed. This integral, and we can do that by integration by parts, or you could probably look it up in a calculus book. I'm kind of looking around for my calculus book, and I don't see it very handy, so let me go ahead and work this on the side. So if you give me a minute here, let me work this one out. If we integrate x e to the x, remember y cubed is a constant, so we'll fold that in later. This, I believe, makes for a great integration by parts. So what you do is you let u equal to x, dv equals to e to the x, then du is dx, and v is e to the x. So remember, integration by parts, the integral of u dv is equal to u times v minus integral of v du. So that's the integration by parts. I know you've seen it before somewhere. This is just a kind of a quick review of it. This incidentally comes from the product rule of differentiation, in case you ever wondered where that came from. Alright, so when I integrate this, I have u times v, x e to the x, minus integral of v du. And so it ends up being x e to the x minus e to the x. Alright, so there we go. So that's the integral of this part. It'll be times y cubed. So I'm going to erase this and rewrite that the way it's supposed to be. Alright, so this part integrated as x e to the x times my constant y cubed minus e to the x times the constant y cubed. Integrate e to the x, we get e to the x plus the additive constant is a function of y, g of y we'll call it. Okay, now do any of those cancel? Yes, they do. E to the xy cubed cancels here. So that's kind of nice. So z was equal to x e to the x y cubed plus e to the x plus g of y. All right. Now, that's really our solution to the differential equation, except equal to a constant, except we have to figure out what g of y is. So I need to do some more erasing here. So to fill in that last blank, what is g of y, I need to take this partial derivative with respect to y and set equal to this part right here. So partial of z with respect to y is the partial with respect to y of x e to the x y cubed plus e to the x plus g of y. Alright, so this partial with respect to y is going to be 3y squared times this. So it's 3x e to the x y squared. That derivative is 0 because it's only in variable x, not in y, plus g prime of y. Now then, I'm going to set this equal to this function. I'm going to multiply that out. So this is 3x e to the x, 3x e to the x y squared, minus minus 18y squared. Multiplying this through. So let's see what we have here. These do match. So I have to solve g prime of y equal to minus 18y squared. Well, my function g of y would be the integral of 18y squared dy. And that would be what? Minus 6y cubed. Alright? Again, we don't need the plus c here because that gets taken care of in the answer to the problem. So we can now write out the solution before we take care of the initial condition. And the solution was my original function. Alright, so it's going to be x e to the x y cubed plus e to the x minus 6y cubed equal to a constant. So there's the answer to the problem. Again, this was the z function we got by integrating this. And then we filled in the blank. We figured out what g of y is. It's minus 6y cubed. And all that equals to a constant. So there's the solution to this differential equation. And the only thing left is to figure out what our constant c is by using our initial condition. So we'll plug that in. When x equals to 0, y equals to 1. So I have 0 e to the 0 1 cubed plus e to the 0 minus 6 times 1 cubed equal to constant. So I let x equal to 0, I let y equal to 1, and this is 0, that's gone. 1 minus 6 is negative 5. So this number is going to be -5 in order to fit everything. And there's the answer to the problem. So, let me check it, make sure I didn't screw up something. E to the xy cubed plus e to the x minus 6y cubed equals -5. Feels good, doesn't it? Alright, so there's your exact differential equations. Kind of a nice change of pace, I think, from the earlier problems that had all that tedious substitution business. Okay, well, our next topic will be, I think, integrating factors, and that's a pretty interesting technique in itself.